Let's derive Snell's law using Fermat's principle. Recall Fermat's principle says that when light travels from one point to another, it does so in the least amount of time. Let's further examine a path of light from one medium into another medium. Let's say from point A in medium 1 to point B in medium 2. Where these two mediums meet, we'll call the interface medium, or the medium interface. And since we have contact between two things, we have normals. So this will be this the interface normal. Now, as light travels from point A in medium 1, it will be refracted as it enters medium 2. The angle on the path of from point A to the medium interface and the interface normal we'll call theta 1 for the incident angle. And from the interface normal to the path to point B from the medium interface we'll call theta 2. That's also known as the angle of refraction. Now, to use Fermat's principle, we need to minimize the time it takes to get from point A to point B. If you'll recall, the time is the ratio of distance and velocity. And as light travels through a medium, its velocity is reduced by what's known as the incident index of refraction, N. So the velocity through medium 1, speed of light through a vacuum, over the index of refraction for medium 1. And similarly for velocity in medium 2, we get the speed of light through the vacuum reduced by the index of refraction for the second medium. Now we need the distances. We can see two triangles in medium 1 and medium 2. We call the distance from point A to the medium interface horizontally as h1, and the same distance to point B, h2. Now, the distance from point A to the medium interface along its path will be given as the hypotenuse of the right triangle in medium 1, and similarly the distance from the medium interface to point B as the hypotenuse of the triangle in the second medium. So the total time then is the distance from point A to the medium interface which is the square root of y squared plus h1 squared over the velocity through medium 1 plus the square root w minus y squared plus h2 squared. Over velocity squared. Now, to minimize this time, we use the first derivative with respect to the independent variable, which is y, as can be seen from the diagram. This will be, of course, 1/2 times y over v1 square root the first derivative of the time function equal to 0 will give us the least amount of time traveled from point A to point B of the light, which reveals the difference of two things equal to 0, which means that these two things are the same. And if we look at the diagram for the path of the light from point A to point B, we notice we have the sine of angle 1. Over the speed through medium 1. And on the other side of the equation, we have the sine of angle 2 divided by the velocity of the light through medium 2. Now, note that the speed of light through the medium can be written as the speed of light through the vacuum over the index of refraction. So if we substitute this ratio for the velocities, we will see a formula relating the angle of incidence to the angle of refraction, known as Snell's law. And there we have it. Snell's law derived from Fermat's principle.